Plant lighting diagrams. Lighting is very important in an industrial plant. Without proper lighting, the plant is a dangerous place to work. In addition, workers have more difficulty doing their jobs without the right amount of light. Working in reduced light can produce eye strain and cause vision problems. For these reasons, you must be able to do an effective job of troubleshooting the wiring when the lighting fails. Several kinds of drawings are used in troubleshooting lighting problems. Complete this next paragraph by filling in the blanks. Press "Check my answer" when you are finished. The blank for the building shows the locations of receptacles, panels, and fixtures. The blank usually includes a detailed layout of fixtures, including mounting directions. That is not correct. Individual specification sheets specify the kind of electrical service and how the service is installed. These sheets also show the locations of outlets and wall switches. Here is a typical lighting diagram. It shows two lighting panels, Panel A and Panel B, located on opposite sides of the building. Exposed electrical conduit runs between the lighting fixtures and the panel boards, indicated by solid lines. Conduit for the receptacles is concealed in the concrete slab, indicated by the dashed lines. The numbers on the drawing, near the arrows pointed toward the lighting panels, indicate the identifying number of the circuit. The circuit breakers in the panel have corresponding numbers. A separate drawing explains how to install the fixtures. Manufacturers' names, catalog numbers, and descriptions are listed in a table. Lighting diagrams show the wiring in the ceilings and walls of a building. They make it possible for you to trace the wiring in the building. For example, if there is power at the main panel, but not at a wall outlet or a ceiling fixture, you know that the trouble is likely to be somewhere between the 2 points. Lighting diagrams and wiring diagrams should be kept in the maintenance or engineering files. Other related diagrams should also be kept there, including drawings that show fixture locations, motor and panel board schedules, and diagrams of the plant telephone, fire alarm, and paging systems. Each of these drawings can help you find trouble spots quickly, reducing the costs of downtime and repairs. Plant lighting controls. Remote control circuits are often used for turning the working circuits on or off. These remote controls operate at low voltage, usually 24 volts. Here is a diagram of a simple remote control relay switching system. A normally open push-button switch allows a small electric current to flow briefly when you press the push button. This current activates the ON coil in a relay. The coil closes the contacts that control a 120-volt lighting circuit. The relay contacts remain closed without further action by the coil. Pressing the OFF button on the low-voltage control activates the OFF coil in the relay. This coil opens the contacts for the 120-volt lighting circuit. The contacts then remain open. Several push-button switches can be installed to operate a single electrical circuit. Electrical troubleshooting charts. A useful diagram for troubleshooting a specific piece of equipment is the troubleshooting chart. This chart is usually developed by the maker of the equipment. It gives step-by-step instructions for testing the equipment. You can see in this troubleshooting chart that each step depends on the result of the previous step. If the result of one test is okay, you go on to the next step. Otherwise, you fix whatever is wrong. Then, see whether the equipment is working again. If not, you continue with the next step on the chart. You can see in the upper left corner of the chart that the trouble with the relay is no contact continuity. The first step in locating the problem is to use a voltmeter to test the power supply to the coil timer circuit. If the incoming voltage is OK, you go on to the next step, which is to check the connections between the timer head and the coil. If the voltage is not OK, you correct the problem in the power supply, then see whether there is contact continuity. Way, making efficient use of your time. Let's practice this method of troubleshooting. Follow along as we solve this problem using the troubleshooting chart. The trouble: there is no contact continuity. With the voltmeter, check supply to coil timer. Check with initiating contact closed to see if input voltage is correct. If not OK, then correct supply problem, blown fuse, etc. If OK, check connections between timer relay to the line, voltage. Remove the timer head and connect coil of relay to line. If not OK, replace timer head. If OK, test is complete. If continuity is OK, replace timer head. Which of the following enables you to form a mental picture of a system? A. Schematic diagram. B. Pictorial diagram. C. Cutaway diagram. D. Isometric diagram. That is correct. A cutaway diagram shows A. The external shapes of parts. B. Components represented by symbols. C. External shape and internal parts. D. That is correct. To show pipes, the simplest piping schematics use A. A single line. B. A double line. That is correct. A double line diagram is easier to read than a single line schematic because the parts A. Are represented by symbols. B. Look more realistic. C. Are labeled. D. Are drawn. That is correct. When you read a hydraulic schematic, you should not A. Use a step-by-step approach. B. Read the symbols. That is correct. On an electrical schematic, subassemblies are outlined by A. Solid lines. That is correct. Which of the following diagrams shows the physical relationships of devices in an electrical system? A. Schematic. B. Subassembly. C. That is correct. The kind of electrical service and its installation are shown on A. A wiring diagram. B. A specification sheet. C. Any. That is not correct. Lighting diagrams show A. The wiring in ceilings and walls. B. Locations of fixtures. C. Mounting directions for fixtures. D. How the service is installed. That is not correct. A troubleshooting chart A. Shows the location of all plant equipment. B. Should be kept in your toolbox. C. That is correct.